Good morning students. Today we will discuss the concept of frequency and wave number of spectral lines in hydrogen atom. Here before going to discuss the concept, there are the two words are there. One is the frequency, another one is wave number. What is the difference between frequency and wave number? First you should know about that one. Frequency, as you know very well, the number of the waves passing through the medium in 1 second, those waves are called as frequency. And here one more word is there, that is wave number. What do you mean by wave number here? The wave number is also the value or magnitude as related with frequency here. If you want to calculate the number of waves with respect of time, then we are going to call it as a frequency. Or if you want to calculate the number of the waves with respect to length, then that is going to call it as wave number. Let us consider with respect to of time the number of waves passing through the medium in 1 second. Those waves are called as, that is frequency, indicated as nu. And here second word is the wave number. What do you mean by wave number? Let us consider this is a distance. This distance is equal to 1 meter. Means I am taking the length now. I am not considering time. I am considering only length. Just you can imagine this length is equal to 1 meter. The number of the waves present or the number of the waves passing through the medium in 1 meter of length. Those waves are called as wave number. The wave number indicating the number of the waves with respect of length, and frequency indicating number of the waves with respect of time. In 1 second, number of the waves passing through the medium is called as a frequency, and in 1 meter of length, the number of the waves passing through the medium, we are going to call it as wave number. Both are wave number, both are number of the waves. We are counting the number of the waves with respect to length. We are counting the number of the waves with respect to time. With respect to time, that is frequency. With respect to length, that is called as wave number. And here, whenever we are going to study about the spectrum produced by the hydrogen atom, we are seeing the number of spectral lines in the spectrum. Those spectral lines, these are having a certain frequency or wavelength. In order to find out the wavelength or frequency or wave number of these spectral lines, we need to use one of the formula. Now in this concept, we need to derive the equation of frequency or equation of wave number. Let us consider here, that is the transition of electron from higher level energy state to lower energy state. Consider an electron jumping from orbit of higher energy level. I am taking that higher energy level as E2. E2 indicating higher energy level. Consider an electron jumping from orbit of higher energy level to lower energy level. That lower energy level I am considering it as E1 energy level. That is, I am taking it as E1 here. Now let us consider the structure of atom. This is the first orbit, this is the second orbit, and this one is the third orbit, and this one is the third orbit. I am taking the transition of electron from second orbit to first orbit. Second orbit, it is nothing but the higher energy level compared to first energy level. I am taking it as E2 and this one as E1. Let us consider the electron is present in the ground state. Whenever if you are passing the electromagnetic radiation through the atom, then what is this electron is doing? This electron absorbing some amount of energy from this radiation. Once the electron absorbing the energy from this radiation, it is taking the transition from ground state to second higher energy state, and within a short interval of time, this electron is not staying continuously in this orbit because that electron became unstable. That's why that electron is not staying in this orbit. Suddenly again that electron is jumping from again second orbit to first orbit. Whenever that electron is jumping from higher orbit to first orbit, it releases energy in the form of electromagnetic radiation. But now we need to find out what is the wavelength or what is the frequency of this radiation. How to find out here? This is higher energy level, this is a lower energy level. Whenever the electron is taking the transition from higher energy level to lower energy level, that electron emits the energy in the form of electromagnetic radiation. How much energy is emitted by this electron? Then how to find out that one? Let us consider there is a formula E is equal to E2 minus E1. What is E2 here? This is energy of electron present in the second orbit. What is E1? This is energy of the electron present in the first orbit. Whenever the electron is jumping from second orbit to first orbit, it releases the energy. What is the value of this energy? Or what is the magnitude of energy of that electron that is going to emit? Whenever the electron is emitting this energy, in order to find out that value of energy that is in, what to do? The energy value of the second state, that is minus energy value of the first state. The difference of these two energies gives the energy of this radiation emitted by the electron. And let us consider here the energy of, consider an electron jumping from orbit of second orbit to first orbit. Then the energy emitted by the electron, energy emitting by the electron is given by difference in energies of difference in energy of E2 and E1. That can be given by, therefore E is equal to E2 minus of E1. And in the yesterday's class we derived that whenever the electron is orbiting in the second orbit or third orbit, whatever is the number of the orbit, whenever the electron is orbiting or revolving in the orbit, its energy can be calculated by using one of the formula. In the yesterday's class you derived that one. Whenever the electron is revolving in the orbit, what is the energy that electron have in that orbit? That can be calculated by using the formula, that is E is equal to total energy we calculated, that is minus m e raised to 4 divided by 8 n square h square epsilon square into z square. This formula you derived in the yesterday's class, because in yesterday we derived the energy equation of the electron whenever it is revolving in orbit. For example, the electron is revolving in the second orbit. It is having a kinetic energy as well as a potential energy. Then the total energy of that electron is equal to sum of potential energy plus kinetic energy. That total energy can be calculated by using this formula. If the electron is present in the second orbit, the energy of that electron can be calculated by using this formula. But what is the value of n here? This is second orbit, means this is 2. And here, whenever the electron is present in first orbit or revolving in the first orbit, its energy can be calculated by using the same formula, that is minus m e raised to 4 z square divided by 8 n square h square epsilon naught square. But here, if the electron is present in the second orbit, its energy can be calculated by using this formula, but number of the orbit is second, that's why take it as n2 and it has E2. Means the energy of electron in which orbit? Second orbit. And next one, whenever the electron is present in the first orbit, its energy can be calculated by using the same formula, but number of the orbit is first, that is n1 square. That's why energy of the electron in the first orbit, that's why I am taking it as E1. And if you subtract this value from this value, you are getting what is the amount of the energy that is emitted by the electron. Substitute that is minus m e raised to 4 z square divided by 8, that is h square epsilon naught square and n square. This is minus. This minus is as it is again bracket. What is even value? That is minus m e raised to 4 z square divided by 8 h square epsilon square and this is n square. This is which orbit? This is first orbit. That's why take it as n1. It is second orbit. This is n1. And next one, this minus and minus becomes plus. Then E is equal to minus m e raised to 4 z square divided by 8 h square epsilon naught square n2 square plus m e raised to 4 z square divided by 8 h square epsilon naught square and n1 square. And what is common here? Just you can take this term first time, this take the term as a second one because it is a plus and it is a minus. And next I am rewriting this one as E is equal to m e raised to 4 z square divided by 8 h square epsilon naught square n1 square. I am taking this term here and this term that side minus m e raised to 4 z square divided by 8 h square epsilon naught square. This is n1 square. What are the common values here? M e raised to 4 z square divided by 8 h square epsilon naught square. It is common at both the side. If you take the common here, that becomes E is equal to, that is m e raised to 4 z square divided by 8 h square epsilon naught square. This is becomes 1 divided by n1 square minus 1 divided by n2 square. This is the formula here. And next one, we know that E is equal to h nu. We know that E is equal to what? That is h into nu. H is a Planck's constant, nu is a frequency of radiation. Then E can be written as h into nu. This is equal to m e raised to 4 z square divided by 8 h square epsilon naught square into 1 by n1 square minus 1 by n2 square. And next here we know that h into frequency is there. The frequency can be written in terms of speed of light, as you know very well. Therefore C is equal to frequency into wavelength. If you multiply these two quantities, one is the frequency, another one is the wavelength. If you multiply, you are getting the speed of the light or speed of that electromagnetic wave. But here I want to take the term as a frequency. That's why C by lambda is equal to nu. Frequency can be written as, that is C by lambda. Therefore h as it is, frequency can be written as C by lambda. This is equal to m e raised to 4 z square divided by 8 h square epsilon naught square. This is 1 by n1 square. This is 1 by n2 square. Next, this one h can be taken in this side. Already here square is there. This 1h and this square become h cube. And this is C by lambda. I am taking 1 by lambda is equal to h into C. I am taking at this side. That's why this is becomes m e raised to 4 z square divided by 8 as it is. This h is coming at this side, h and h square, that becomes h cube. And next C as it is, I am taking C here. And next this is epsilon naught square. And again this is 1 by n1 square minus 1 by n2 square. Next we can simplify further. This becomes this equation. This is 1 by lambda. 1 by lambda is equal to 1 by lambda is equal to this term is there. M e raised to 4 z square don't substitute z value is equal to 1, because if you substitute z value is equal to 1, immediately the equation is considered as per the atom, that is hydrogen, but I am not considering hydrogen atom now. That's why substitute as it is 8, that is h cube speed of light into electric permittivity square, remaining equation 1 by n1 square minus 1 by n2 square. And next, if you substitute the value of mass of the electron, here m is mass of the electron and e is charge of the electron, and z is, just you can take this one for hydrogen atom is take z is equal to 1, and next 8 as it is Planck's constant, speed of light 3 into 10 to the power 8 meter per second, and epsilon naught value as you know very well, that is electric permittivity. Its value is 8.854 into 10 to the power of minus 12 per 8 meter. This is 3 into 10 to the power 8. This is 6.662 into 10 to the power minus 34 joule second. Mass of the electron 9.1 into 10 to the power minus 31 kg. Charge of the electron 1.6 into 10 to the power minus 19 coulomb. And for hydrogen atom, z you can substitute, that is 1. And if you calculate all this one, you are getting the answer, that is equal to, that is the constant value. I am taking r 1 by lambda is equal to, I am taking here r is equal to, this term is equal to r I am considered, remaining is 1 by n1 square minus 1 by n2 square. I considered r is equal to this term, r is equal to this term. If you calculate the r by substituting all these values, you are getting the r value is equal to, you are getting r is equal to 1.097 into 10 to the power of 7 per meter. If you calculate r is equal to this one, r is equal to this term, just you can substitute all the values and that is need not to be calculation. And if you calculate r is equal to, you are getting 1.097 into 10 to the power of 7 per meter. This r is constant for every atom, whatever it is the atom, this r should be constant. That's why this r value we are going to call it as, let us take this is for hydrogen atom, that's why this is becomes 1. And if you calculate r, you are getting this much of answer, and this value is constant, and this value we are going to call it as, this is Rydberg constant. This is Rydberg constant. Rydberg's constant. This is the name of the scientist who found out this value. His name is Johannes Rydberg. He given this value for calculation of wave number or wavelength of each and every spectral line. This value is constant for every spectral line. That's why that value is equal to 1.097 into 10 to the power 7 meter. And his name is Johannes Rydberg. And that's why this is the value named after that scientist. And here 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. This value, this answer is this much. And therefore the final equation, this is nu bar is equal to r 1 by lambda is equal to, this is equal to this one. This is called as a wave number. What is nu bar? This is wave number. Here term is not a t. If it is a t, instead of lambda, if it is a t, then this becomes frequency. This becomes frequency. But now I am not considering the frequency. I am taking it as a wave number, because here lambda is there. Lambda in the sense that is the time or length. This is length. With respect to length, we are not calling it as a frequency. With respect to length, we are considering it as a wave number. If instead of lambda, if t is there, this quantity is length or time, this is time, then you can take it as a frequency. But here lambda is there, that's why with respect to length, wavelength, that is the magnitude indicating a length, that's why with respect to the length, number of waves is called as a wave number. That is, wave number is equal to 1 by lambda. Or else you can define what do you mean by wave number. The wave number is, that is inverse of the wavelength of spectral lines or electromagnetic radiation, or this is here wave number and lambda are inversely proportional. With respect to length, the number of the waves we are going to call it as a wave number. Don't take it as a frequency. That's why wave number or 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. And here just you can remember very clearly, this nu bar is not a frequency. This is wave number. This is wave number. Wave number, this is wavelength. Inverse of wavelength is called as a wave number. Or inverse of time is called as a frequency. With respect to wavelength, this is a wave number. Wave number or 1 by lambda is equal to, this is the formula. Here if you want to find out frequency, what we can do again? Here 1 by lambda is nothing but a wave number, or nu bar is nothing but a wave number. Or if you want to find out the frequency, you know very well, that is C is equal to nu into lambda. And here nu can be written as C by lambda is equal to nu. Take C in this side, then this is 1 by lambda is equal to nu by C. And here 1 by lambda, this is called as a wave number, this is equal to frequency divided by C. And here if you want to find out the frequency, just you can take this one is C divided by lambda. C divided by lambda is equal to frequency. But 1 divided by lambda is not a frequency, that is wave number. That's what the wave number, or that is a wavelength is equal to, inverse of wavelength is equal to r into this one. And how to use this formula? Let us consider here. This is the atom. If the electron is jumping from second orbit to first orbit, if the electron is jumping from second orbit to first orbit, it is emitting the radiation, and its wavelength or its wave number can be calculated by using this formula. It is taking the transition from second to first, means n2 is equal to, that is n2 is equal to 2, and what is n1? n1 is equal to 1. Or if the electron is taking the transition from third orbit to second orbit, n2 becomes 3 and n1 becomes 2, and this value is constant. You can find out either wave number value or else wavelength value. Or if the electron is jumping from infinity orbit to third orbit, then n2 becomes infinity and n1 becomes 3. Or if it is jumping from 10th orbit to first orbit, n2 becomes 10th, n1 becomes 1. By substituting, this is a constant value. By substituting all the values, we can find out wave number, or else we can find out that is wavelength of the given spectral line. This is nu bar is equal to r. Nu bar or 1 by lambda is equal to, this is the formula. It means that nu bar is equal to r into 1 by n1 square minus 1 by n2 square, or 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. By using this formula, we are going to find out wave number of each and every spectral line, and this is the formula. Just you can remember, you are getting one numerical on this formula. Based on this formula, you are getting the numerical for 5 marks. And here this is not a frequency, this is a wave number, this is a wavelength. And if you find, and how to find out the frequency by using this formula. If you want to find out the frequency, first you have to find out lambda value. After that, C by lambda, you are getting the frequency. This is frequency, this is wave number, and just you can remember. And this is the derivation important for 3 marks, as well as based on this formula there is a numerical for 5 marks. Just you can remember this formula, and also remember the value of Rydberg constant. Johannes Rydberg, he given the value to find out, he given the constant value to find out the wavelength or frequency or wave number of each and every spectral line. He given the value, that value is called as 1.097 into 10 to the power 7 per meter. This value is also they are asking for 1 marks. And how to get this value? By using this formula. Rydberg constant is equal to R is equal to, this is m e raised to 4 divided by 8 h cube c into epsilon naught square. If you substitute all the quantities in the given equation, we are getting the R value, that is the magnitude is equal to this much. And remember this formula. And thank you.